we have here interpolation. So there are many ways to interpolate. Now this time we will do the linear interpolation. A function is said to interpolate a set of data points if it passes through those points. So for example, this one, we have our x coordinate and y coordinate. We have here 3 points, okay, 3 points, and then for these 3 points we have here a line that passes through these 3 points. So this line is called the interpolant. Okay, so based on this graph, this is line, we call this one as linear interpolation. Now we go directly to our example of linear interpolation. Given the following, the time in terms of seconds, we have here the time, and then the velocity, wherein the units is meter per second, given this one. Okay. Now for example, at time 0, the velocity is 0. When the time is 10 seconds, its velocity is 227.04. At t equals 15 seconds, its velocity increases to 362.78, and so on. Now there is a question here. Find the velocity or v of t if the time is 25 seconds. Okay, if you have noticed here, there is no equivalent of t at 25. Now, to solve this problem, we will use linear interpolation or interpolation. Simply the word interpolation. Now, notice the time is 25. So, we have to base our time from this data wherein this 25 is within 20 and 30. So, this time, we will pick up this 20 and 30 and then write 25. So, we have 20. Okay, I will write here 20, and then 25, which will be at the mid, and then 30. Okay, the equivalent velocity of 20 is equivalent to 517. Okay, 517.35. The equivalent of 25 is unknown, so we have to determine the unknown. So we will write here x. Okay, sorry, x. Okay, no, it will not write. So we have here x, and then 30 is 901.67. So I will write here 901.67. Now, using interpolation, this is unknown, so I will write this. I will draw here this one. If I will draw a line here, then I will draw also on the other side. This is a combination of this one, and then on the other side is the time combination, and then I will draw here another combination, Okay, now to write an equation, I will write first x by using this. Let's say this is our guide, x minus, so we have here, by the way, in interpolation, linear interpolation, it is similar to ratio and proportion. Okay, so x minus 517.35 over, so on the other side that becomes 25 minus 20. 25 minus 20. Okay, and then that is equivalent to, so it's similar to ratio and proportion. This one is 901.67. Okay, 901.67 minus 517.35 divided by, so if this is our path, then we have this one, 30 minus 20. 30 minus 20. Okay, so that this one, x minus, okay, I will write here x minus, so I will transfer this one to the other side. That is cross multiplication. So this one multiplied here. So we have, the result is, let's say, x minus 517.35. That is equivalent to, this one 25 minus 20 is equivalent to 5. 5 times this one, the equivalent of this one is 901.67 minus 517.35, okay, divided by 30 minus 20, that is equivalent to 10. And so we can find the value of x as x is equivalent to, this one will be transferred to the other side, that becomes positive. So 517.35, that is equivalent to 5 divided by 10, that is 2, or 1/2, plus 1/2, and then the equivalent of this one, so I will write here 901.67 minus 517.35, so that your x is equivalent to, so using your calculator, the equivalent of x is, let's say, 709. You can check your calculator, 0.51. So that is linear interpolation. So what you will do here is, of course, if this is 20 and 30, and then we're going to find when t is at 25, you will pick up 20 and 30, the range wherein this t is or can be found. So that is within 20 and 30. So you pick up this 20 and 30, and then you put this 25 at the midst of 20 and 30, and then write the equivalent v of t, our velocity. For 20 we have this value, for 30 we have already this value, and then for 25 this is the unknown, so we will write x, and then we will draw a path. This one we will combine this one, okay, and then if we draw here, we will also draw on the other side, and then if we draw here, we will draw on also on the other side, okay, and then just follow this path. This is some kind of doing ratio and proportion. This one equals this one. So this is how we do the interpolation. Now what if we have we're going to find the velocity if t is equivalent to, let's say, 11. So if 11, then we will pick up 10 and 15. Okay. On the other side, if given is the velocity, let's say if the velocity is around 400 something, that is 425.38 for example, so we will pick up this one, and then this time will be our x.